Welcome. We're going to talk about complex numbers today. Specifically, we're going to first look at what is a complex number, what are the parts of a complex number, then how do we utilize our basic operations, adding, subtracting, multiplying, and dividing complex numbers. So to start, simply a complex number has two parts to it. They are written in their standard form, a plus bi, where a represents the real part of this complex number, and the bi term represents the complex, not complex part, the imaginary part. So complex numbers have two parts, real parts and imaginary parts. And the part that makes them complex is that imaginary part. If they did not have that, if b was 0, so we have to say b can't be 0, because if it was, then we would just have a real number. Now let's look at how do we add and subtract complex numbers. So adding and subtracting complex numbers follow really the same pattern. Let's say we've got two complex numbers. The first one is going to be a plus bi, and we're going to add c plus di. Now remember, I is the number we get when we take the square root of -1. So if we are going to add these, all we're going to do is we're going to add the real parts. So we're going to go a plus c, and then we're going to add to that, adding the imaginary parts. We're going to go b plus d times I. Subtraction is pretty much the same. If we have a plus bi and we subtract c plus di, we're going to get a minus c plus b minus d times I. So let's look at a couple examples of how we would actually do that. So example 1, we'll look at like 4 different complex numbers that utilize addition and subtraction. So 1a, we're going to add 4 plus 7i add that with 1 minus 6i. So we're going to just go and add the real parts. We're going to go 4 plus 1 plus 7i minus 6i. Well, 4 plus 1, that's 5. 7i minus 6i, that's going to give me plus I. So my answer is going to be just 5 plus I. Let's look at another one. Let's take 1 plus 2i and add 3 minus 2i. So we're going to go 1 plus 3 and then we're going to add 2i minus 2i. Well, 2i minus 2i is 0 and 1 plus 3 is 4, so we're going to be left with just 4. Let's look at 2 more. We're going to go 3i and we're going to subtract -2 plus 3i. Now we don't have a real part to this, so hold on. I've got a little bit more to this one even. We're going to subtract again 2 plus 5i. So we're going to be subtracting 3 complex numbers. Now, there is a real part to that first one with the 3i. The real part is just 0. So we're going to go 0. If we minus a negative 2, that's the same as adding 2. Minus, we've got another 2. Then we add to that 3i minus 3i plus 5i. So in our real part, 0 plus 2 minus 2, that's 0. 3i minus 3i is 0. 0 plus 5i. And I actually made a mistake writing something here. It's not plus 5i, it's minus 5i. So our answer is going to end up being just a negative 5i. Let's look at one last one before we move on to the next operation. So we're going to take 3 plus 2i. We're going to add 4 minus I. And then subtract 7 plus I. We're going to go 3 plus 4. We're going to take care of the real parts. And then minus 7 from that. And then we're going to take care of the imaginary parts. 2i minus I minus I. Well, 3 plus 4 is 7. 7 minus 7 is 0. So our real part is 0. 2i minus I also makes 0. So we're just going to end up with a big 0 for that one. The next operation we're going to look at is multiplying complex numbers. So when we multiply complex numbers, all we're going to do is FOIL it. We're going to treat it like we're multiplying two binomials. So if we have a plus bi, and we're multiplying it by c plus di, we're going to go a times c plus a times di plus c times bi plus b times di squared. And if you remember from Algebra 2, I squared is actually equal to negative 1. So we can rewrite this. We can write it as a times c plus, now I'm going to just, with my two terms that have an I, I'm going to write it as AD plus CB in parentheses times I minus BD, and then I'm going to just move some things around. I'm going to move using the transitive property, commutative property, excuse me. I'm just going to move the minus BD to be closer to AC. So we can write this as AC, A times C minus BD plus AD plus CB times I. Now that looks funny, but really you're just foiling. So let's look at an example. This will be example 2. We're going to look at first 4 times negative 2 plus 3i. Now this is just a real number times a complex number. So all I need to do is distribute the negative 4 in. Negative 4 times 4 times negative 2 gives me negative 8. And 4 times 3i gives me plus 12i. Once we've distributed, we've finished multiplying. If we have, say, two binomials, 2 minus I times 4 plus 3i, we can go 2 times 4, which is 8, and then 2 times 3i, which is 6i, negative I times 4, so minus 4i, negative I times 3i, minus 3i squared, and I squared is the same as negative 1. So we're going to have 8, 6 minus 4i, that is plus 2i, minus 3 times negative 1. Well, if we multiply negative 1 by that minus 3, it's just going to turn into plus 3. So we're going to have 8 plus 2i plus 3, and 8 plus 3 is 11, so we're going to have 11 plus 2i. And putting it into standard form would simply be just having it in this a plus bi format. Let's look at 2 more. We're going to have 3 plus 2i times 3 minus 2i. So we're going to go 3 times 3, 9, 3 times 2i minus 6i, 2i times 3 plus 6i, and 2i times negative 2i is minus 2i squared, which the middle terms are going to cancel out. I squared is negative 1, so we're going to have 9 plus 2. Correction, I did not go 2 times 2, so I made a mistake. It's not minus 2i squared, it should be minus 4i squared, which means we're going to have 9 plus 4, which is 13. And then let's look at one last one. We're going to take 3 plus 2i, and we're going to square that, which, remember, squaring a binomial means we're just having 3 plus 2i times 3 plus 2i. We're going to have a 9 plus 6i plus 6i plus 4i squared, and i squared is negative 1, so we're going to have 9 minus 4, which is 5, and 6i plus 6i makes 12i. So we're going to have 5 plus 12i. And I think we're good at looking at examples of multiplying complex numbers. Now, before we look at dividing complex numbers, we need to know what the complex conjugate is. Now, all it says for the complex conjugate is given a plus bi, the complex conjugate is a minus bi. And when we multiply those together, the a plus bi and the a minus bi, all we're going to be left with is a squared plus b squared. You can FOIL it out and you'll find out that all you're going to be left with is a squared plus b squared. So let's look at some examples of multiplying by the complex conjugate. So example 3. We're going to multiply by complex conjugate. And we're just going to do 2 of these. We're going to take 1 plus I and multiply it by its complex conjugate. So we're going to go 1 plus I times 1 minus I, which from the little bit above means we're just going to take 1 squared. Now there is technically a number in front of that I, and that's our b part, and that number is 1. So it's 1 squared plus 1 squared. Well, 1 squared is 1, and 1 plus 1 is 2. So 1 plus I multiplied by its complex conjugate is just 2. Let's look at 4 minus 3i as well. So 4 minus 3i's complex conjugate is just going to be 4 plus 3i. And we know that multiplying the complex conjugate, the two numbers that are complex conjugates, is just going to result in the real part squared plus the b term squared. 4 squared is 16. 3 squared is 9. 16 plus 9 makes 25. So 4 minus 3i times 4 plus 3i makes 25. Now we're going to look at dividing complex numbers next, and we needed to know about that complex conjugate because it is something we're going to use when we divide complex numbers. So the process of multiplying or dividing complex conjugates is to multiply the numerator and denominator by the complex conjugate of the denominator. And to simplify. So let's look at an example. Now, I've just got one for this one. So example 4. We're going to take 2 plus 3i and divide it by 4 minus 2i. So we need to multiply by the complex conjugate of our denominator. So we're going to take 2 plus 3i over 4 minus 2i. We're going to multiply both of those by 4 plus 2i. The point of doing this is we're trying to put it into standard form, and we don't like having imaginary numbers in the denominator of any type of fraction. Now, in our denominator, we're just going to have 4 squared plus 2 squared. We talked about that in the last slide. In our numerator, we're going to have to go 2 times 4, which is 8, 2 times 2i, so we're going to get a plus 4i, 3i times 4, we're going to get a plus 12i, and 3i times 2i is going to give us a minus 6, because it would be 6i squared. So I'm just taking care of I squared right away by writing minus 6. So 8 minus 6 is 2. 4i plus 12i is going to give us 16i. 4 squared is 16. 2 squared is 4, so we're going to get 2 plus 16i over 20. Now, all three terms here are divisible by 2, so I'm going to divide everything by 2, and I'm going to get my final answer to be 1 plus 8i over 10. And we're done. Now, some people would also maybe write this as 1/10 plus, and then simplify 8 over 10 to 4/5. I would take that, but I'm also fine with you leaving it as 1 plus 8i all divided by 10. That's going to wrap up our little lesson on complex numbers.